Welcome. Let us discuss few more problems on vector. Our first problem today is the value of I dot j cross k plus j dot k cross I plus k dot I cross j is. Options are 0, 3, 2 and 1. Actually, we know that I cross j is equal to k. J cross k is equal to I and k cross I is equal to j. That is when these components, say I, j, k, they are in that order. I cross j, it will be equal to k. J cross k, it is I, and so on. But I cross k, this is it is anti-clockwise direction. Then I cross k is equal to minus j. K cross j is equal to minus I, and so on. In this case, it is equal to I dot j cross k. J cross k is equal to I. J cross k is equal to I plus j dot k cross I. K cross I is with j plus k dot I cross j k. Now it is equal to I dot I. I, j, k, they are unit vectors along x-axis, y-axis and z-axis. So this is equal to 1 into cos 0 is again 1. So it is 1. By same reason it is 1. So 3 answer. So this option is correct. Next. Next problem is, before starting next problem, I discuss one result. A, B, C are any three vectors, then A cross B cross C. It is equal to cross product of three vectors. If components are given, we can find B cross C, it is a vector. Then cross product of A with that vector, again with the help of determinant, we can do that. But it's a lengthy process. Actually, it is formalized, it is equal to A dot C away, that vector is away. So A dot C into B vector, inner vector, minus A dot B into outer vector C. A cross B cross C is equal to that. So now the next problem is, if A cross B, comma, B cross C, comma, C cross A is equal to lambda times ABC. Now it is actually vector triple product of three vectors, this and that. They are all vectors. It is equal to lambda times this triple product ABC. Then value of lambda is, options are 4, 2, -1 and 1. It is given in JEE main 14. So we use this result. Left hand side, this into that, it is equal to A cross B dot this is meaning of that. Let us suppose that it is equal to a new vector, say u, so that it is equal to A cross B dot u cross C cross A. It is equal to A cross B dot, it is like that, A cross B cross C, u cross A into C vector minus u cross u dot not cross. Next, u dot C into A vector is equal to A cross B dot u means A B cross C dot A minus u again B cross C into A vector, all vectors. It is equal to A cross B dot, it is B cross C A, B cross C A and A dot B cross C, same thing, A dot B cross C, so that it is equal to ABC. And A cross B dot, this is ABC into C vector. This is scalar quantity, this is a vector quantity. So dot product of this with that is permissible, minus u cross C. U is equal to B cross C dot C. This is a dot triple product. Here these two components are same, so this is equal to 0. So that we get it as A cross B dot C into ABC. This is nothing but ABC. ABC. So it is equal to ABC whole square. Oh, it is, just a minute. Somewhere I have mistaken somewhere. A cross B dot oh sorry, given that this is whole square, very sorry, given that this is equal to lambda times this whole square, so we get it is equal to whole square. So lambda, value of lambda is equal to 1 into whole square. Given that this is equal to lambda into that, we get this is equal to 1 into this, so lambda is equal to 1. So this option is correct. Next, next problem is ABC are unit vectors such that A cross B cross C is equal to root 3 by 2 into B plus C. If B is not parallel to B is not parallel to C, find angle between A and B, all vectors. They are all vectors, and all vectors. So it is given that this is equal to that. We have to find angle between A and B. And moreover, it is given that B is not parallel to C. If B is parallel to C, in that case, this is 0, because magnitude B, magnitude C into sine 0 means 0. In that case, it would be 0. That's why it is given that this is not parallel to C. Now, we have to find the angle between A and B. Now, with the previous result, this is equal to this one is equal to A dot, A dot. It is equal to A dot C into B vector minus A dot B into C vector, and that is given as root 3 by 2 B plus C vector. All vectors, find that. Here we get one equation. Equating coefficients of vector B from both sides, A dot C is equal to root 3 by 2 and minus A dot B, coefficient of C vector, is equal to minus root 3 by 2 vectors. Then, this is minus, why this is not negative. So A dot B is minus of that. That is magnitude A, magnitude B into cos theta, where theta is the angle between A and B, is equal to minus root 3 by 2. But mind that ABC are all unit vectors. This is 1, so cos theta is equal to minus root 3 by 2. Oh, options are not given. Options are 5 by 3. I'm giving option here. 5 by pi by 3, pi by 4, 5 pi by 6, and pi by 2. Now cos theta is equal to that. It is negative, so it lies on second quadrant. It is equal to cos of 5 pi by 6, pi plus pi by 6. So theta is equal to 5 pi by 6. So this option is correct. Now our next problem. if AB, vector AB is equal to 3i plus AB is equal to 3i plus 4k, AC vector is equal to 5i minus 2j plus 4k are two sides of the triangle ABC, then length of the median through A is options root 33, then 6 root 2, then 7 root 2 and 7. That problem was given in JEE main in the year 16. Oh, not 16. That is given in the year 13. Achha, here it is given that these two are sides of a triangle ABC. A, B, C. In that case, let us suppose that A is the origin. A is origin, so AB vector, this is position vector of B is 3i plus 4k, and AC, and because A is origin of reference, so C is the position vector, that is this 5i minus 2j plus 4k. Now we have to find the length of median through A, that is if D is midpoint of BC, then we have to find the distance AB, length AB. Now D, which is midpoint of B and C, it is equal to 4i. This is 5i, this is 3i, 8i by 2. J is 0 here, minus 2j by 2, that is j. 4k plus 4k by 2, that is again 4k. So position vector of B is this, and A is origin, we have taken. So magnitude AD, that is magnitude AD is equal to root over of 4 square, that is 16, plus minus 1 whole square, 1, plus 4 square, 16. So root 33 is answer. So this is root 33, that is correct option. Next problem. Next problem is A, vector A is equal to 3i minus 2j plus 2k. B is equal to I minus 3j plus 2k are two vectors, and C is a unit vector such that, C is a unit vector, then maximum value of box A, B, C. Now, options. Maximum value of this 2 root 69, then 15, 14, and root 69. We know that box A, B, C, this is equal to A dot B cross C. This can be written as A dot maximum value of C. It can be written as A cross B dot C. Cyclic way, we can change it. So A cross B dot C. Now, it is equal to, okay, I write it up to this. Let us suppose that this is 1. Now, A cross B can be, its components are given. It can be obtained by using the determinant component of A 3 minus 2 2, 1 minus 3 2, so that it is equal to I into minus 4 plus 6 into I plus then 2 j minus 6 into j k plus k is minus 9 plus 2, so that it is equal to I 2i minus 4j minus 7k. Just 1 minute. 2 minus 4, this is minus 7. So magnitude A cross B, it is equal to root over of 2 square, that is 4, minus 4 whole square, minus 7 whole square, that is 49. It is root over of 2069. Now, we have to find the maximum value of that, that is maximum value of that A cross B dot C is equal to magnitude A cross B into magnitude C and cos theta, where theta is the angle between this and that. Theta is the angle between this and that. So magnitude A cross B is equal to, just now we obtained, it is 69. Magnitude of C, it is given, it is unit vector into 1 and cos theta. So value of this is that, so it is constant. So value depends on theta, that is on cos theta. Maximum value of cos theta is 1, hence maximum value of this thing is root 69, that is this. Our next problem. Let A is equal to vector A 2i plus 3j minus k, B vector is equal to I minus 2j plus 3k are two vectors, and C is a vector perpendicular to both A and B and satisfies C dot 2i minus j plus k is equal to minus 6, then C is options I minus j minus k minus 3 into I minus j plus k or minus k, sorry. Third, 4 into I minus I plus j minus k and minus 4 into I plus j minus k. Now let us see what is the problem, actual problem. A and B are any two given vectors. A and B are two given vectors, and C vector is a vector perpendicular to both A and B. C is the vector perpendicular to this and that also. Then, and C also satisfies this. C also satisfies this vector, this equation. Then, to find value of C, number 1, number 2, 4 options are there. So, as because C is a vector perpendicular to both A and C, so C is can be obtained from A cross B. A cross B is equal to I, J, K, then component of A, that is 2, 3, minus 1, and 1, minus 2, and 3. So that it is equal to I into 9 minus 3 minus S, so minus 2 into I, plus j into minus 1 minus 6 into j, plus k into minus 2 minus 4 minus 3 into k. So that 7i minus 7j minus 7k. This is the vector A cross B. So C vector is along that. Suppose that C is equal to some constant multiple of that, 7i minus, rather, that's okay, 7i minus 7j minus 7k. Well, 7 can be taken common. Again, given that this condition is true, C dot 2i minus j plus k is equal to minus 6. That is 7 lambda, I have taken 7 common from there, 7 lambda into I minus j minus k dot 2i minus j plus k is equal to minus 6. That is 7 lambda into this is equal to plus 2, this into that, plus 2, plus 1, minus 1 is equal to minus 6. This is, they together is 2. So 7 lambda is equal to minus 3. Now our C is equal to this, this, that is 7 lambda, this one, 7 lambda into I minus j minus k. So C is equal to 7 lambda into that. But we get 7 lambda is equal to minus 3. Therefore, C is equal to minus 3 times I minus j minus k. Minus 3 into I, this one. So this is correct option. Acha. Next problem is, let P, Q, R, S are points whose position vectors are minus 2i minus j, 4i, next 3i plus 3j, and minus 3i plus 2j. So this is position vector of P, this is position vector of Q, and so on. These are given. Then question is, PQ RS is a rhombus, number 1, but not square. This is square. Rectangle, next one is rectangle not square. Third one is square. And fourth one is parallelogram but not rhombus. And not rhombus and not rectangle. So it is very clear, 4 points are given. So it is a four-sided figure, PQRS. Suppose this is the figure PQRS. Now PQ, this is P, Q, R, this is S. So PQ vector, position vector of Q minus position vector of R, that is 4i minus, that is 6i minus j. This is PQ vector. QS vector, QS. Oh, suppose PQ, this is R, this is S. QR vector, position vector of R minus that is minus I, 3i minus 4i plus 3j. RS vector, position vector of S minus that is 6i minus j. SP vector is position vector of P minus position vector of S, that is position vector of P, that is this minus that is, it is I, this minus that is position vector of P, that is minus 2i plus 3, so plus that, and minus j minus, so it is equal to minus 3j. This is the, now it is clear from that that PQ is parallel to RS. PQ is this, RS is this, same vector. So vector PQ and vector SR, they are equal vector and magnitude also equal. So this is a equal and parallel. So it is a parallelogram. Number one, parallelogram. Now we have to test whether it is a rectangle or square, etc. Rhombus, that's these things. If angle between this is 90 degree, then it may be rectangle or square. Now PQ vector dot PS vector, SP, this and that. So 6i, so it is equal to 6 plus 3. This is at least not 0. So this is not 90 degree. So this is not a square, not a rectangle. And we have to, it is not a rectangle. Now we have to find whether it is a rhombus or not. PQ vector, magnitude PQ is equal to root over 36 plus 1, 37. And magnitude of PS or SP, root over of 1 plus 9, that is 10. This magnitude of this is not equal to that, so it is not a rhombus. So this is parallelogram we have followed. Then we proved that this is not rectangle, this is not rhombus. So this one, this is correct option. Yes. Thank you. Today is up to this. If you feel that this helps you a lot, then please like it, share it, and subscribe it. Once again, thank you.